Hello. In order to address particular tasks of the access control system, the technical characteristics of certain reading devices can be utilized, such as the capability to identify whether a card is present or absent within the operating area of the reader. This allows building various logics based on data about the prolonged presence of the card in the reading area, capable of improving individual system functions and, for example, increasing the level of access strictness to different equipment. This functionality is exactly implemented in presence readers. Such devices typically differ in how they interact with the card. The simplest option is to detect the physical presence of the card. For example, when the card is placed in the reader, it presses a button. In another case, the presence of the card can be determined by reading its code, and based on this, more complex logic can be implemented. For instance, after placing the card and reading its code, the system will check the access rules to the room for the card owner to ensure authorized entry. Historically, the first devices of this kind were readers with iButton and touch memory interfaces. These are a separate class of devices with a single-wire information exchange protocol known as one-wire. When using this interface, reading the unique identifier occurs at the moment of physical contact between the key and the reader. In other words, these are literally contact keys, with the simplest example being intercom tablets. It was thanks to such technology that the capability to control key retention by the requier initially appeared using iButton and touch memory devices. However, devices based on the iButton and touch memory interfaces are typically not cryptographically secure, meaning they are not protected from copying and do not have the ability to operate in a secure mode, so it would be rational to use them only if there are no high security requirements at the facility. For tasks where it is necessary to utilize a presence reader and maintain the security level at the facility, more commonly used access interfaces such as Wiegand and OSDP can be employed to establish connections with devices. It should be noted that such a mode of operation must be additionally supported by the manufacturers of the reader and controller. On our part, we have added support for this logic in the system. Currently, the presence reader logic is supported by controllers of E510, E2, and E4 models. The differences lie only in the communication interfaces used by the reader controller. Touch Memory and Wiegand on E510, Wiegand and OSDP on E2 and E4 models. Now let's talk about the possibilities that the use of a presence reader opens up in access systems. In addition to the main task of simply opening an access point by placing a card in the pocket, various other logics can also be built. Some of the most popular examples include power management and tracking the working hours of staff with high accuracy. Let me tell you a bit more about these use cases. For instance, power management is a standard practice for hotels and resorts. The reader's utilization and presence enable the detection of the presence or absence of a valid card within its operating range. Accordingly, if the card is not inserted into the special pocket, the number is automatically de-energized. In the case of a manufacturing plant, access to any equipment, for example a machine, can be blocked. As soon as the operator moves away from the equipment taking the card, access to it is blocked. And the second logic is the most accurate recording of each employee's working time. When arriving at work, the employee places the card into the reader installed right next to their workstation. If this card is utilized for accessing other company premises, the employee will need to take the card while departing from the workplace in order to have the ability to return. Thus, time tracking becomes more precise, as only the actual time spent at the workplace is taken into consideration. As a result, the employee's salary is accurately calculated. Additionally, based on this information, a standardized time worked report and other analytical reports can be automatically generated. Now let's talk about how to connect the Sigur controller with the presence reader and set the necessary settings for the system to function. Start by connecting a touch memory interface reader to the Sigur E510 controller using the Matrix 3 as an example. For connection, GND, Data 0, LED 2 terminals are used, and if necessary for indicator control, LED 1. According to the diagram from the controller manual, connect the reader's power line to the VR Plus and GND terminals of the controller. Also, connect the brown wire of the reader, which is common, to the GND terminal. Now let's connect the actual interface, the white wire of the reader, to the Data 0 terminal, and make sure to connect a jumper between the Data 0 and LED 2 terminals of the controller, then restart the controller by power cycling. It is important to note here that such a scheme is necessary for the controller to identify the connected reader as touch memory specifically. This means that at the time of powering on the controller, a jumper must be installed between the Data 0 and LED 2 terminals. If the jumper is not installed at the time of power supply, the controller will wait for the reader to be connected via the Wiegand interface, and the touch memory reader will not function. Now let's move on to the settings in the software interface. And let's start with a scenario where it's necessary to control the power line of an external device by placing a card in the reader, whether it's lighting in a room or a machine in a production facility. Let us proceed to open the client program. On the Equipment tab, we need to carefully select the necessary access point and then navigate to its settings to make the required adjustments. In this step, we will uncheck the box labeled Display Only Basic Settings to disable this option and show all settings. To ensure proper operation, specify the pocket reader as a reader of unknown direction. In the corresponding parameter, specify the controller's port used. Following that, we proceed to locate the parameter known as card hold signal in front of the reader and specify the output that is utilized by the controller in order to effectively control the power line of the external device connected to it. After that, we will press OK to save the settings. This line is activated when the card is held within the reader's operating range. The exit will stay in an active state until the card is taken out. Now let's verify the functionality and ensure it is working as expected. To do this, we will place a valid card in the pocket. The card is successfully detected within the reader's range. The controller detected the hold and activated the relay that was selected in the settings. Once the card is removed, the relay deactivates. Now let's talk about the most accurate calculation of working time. And let's consider it using the example of the E4 controller with MR100 series readers connected to it via Wiegand and OSDP interfaces. It's important to note that when using the presence reader logic via Wiegand and OSDP interfaces in Sigur, there are specific requirements. For Sigur MR100 series readers, their firmware version must be 45 or higher. The controller firmware version should be 0, 20.0 or higher. Third-party readers that are connected via Wiegand must have the capability to continuously transmit the read identifier code to the controller as long as the card is held within the range of the reader. Since the readers are connected to the controller, let's proceed to the software settings. First, we need to configure the Sigur readers to switch operating mode. To perform this action in the client application, you must navigate to the File, Settings, Contactless Identification menu, and ensure to activate the checkbox labeled Use Card Hold function in front of the reader. Then proceed to upload this specific configuration to the reader device for proper functionality. We provide a detailed explanation on how to program the reader using figures in separate videos. Subsequently, we proceed to open the Equipment tab, choose the required access point, and navigate to its settings in order to make the necessary configurations. In the Settings Editing window, we again specify the pocket readers as readers of unknown direction. In my case, I will specify the readers for 2 access points. In the case of Wiegand, I employed port 4 and will explicitly specify it on the tab labeled Access Point 1. For OSDP, on the AP2 tab, I'll specify the used port 1. Next step is, on the first access point, I will also set the card hold signal parameter in front of the reader and specify the outputs used by the controller to manage the power line of external devices, such as machines. Next, we proceed to the General tab. In this section, it is imperative to configure the time parameters that will determine the functioning of the card hold logic on the system. Let's begin with the max card waiting time in case of hold and hold delay after the card is removed parameters. They adjust a specific delay prior to the controller activating or deactivating the configured card hold logic by the reader. We will leave their values at default. Let's move on to the parameter minimum card hold time by the reader. This is the time after which the card hold by the reader is determined. For example, let's set it to 500 milliseconds. Here we will also check the box Mark Entry Exit by Room and Card Removal. This parameter precisely allows the reader to be used for tracking an employee's presence time in a specific location. Inserting a card into a pocket-type reader will result in the generation of an entry event, while extracting it will trigger an exit event. At this stage, the software interface configuration is done, and we can now test the configured functions. To start, let's bring the card close to the reader connected via the Wiegand interface. The reader successfully read the card. After that, the controller detected the card hold in front of the reader, registered the entry passage, and activated the selected relays in the settings. When the card is removed, the controller registered the exit passage and deactivated the relay. The same setting works on the reader connected via the OSDP interface. All arrival and departure events can be seen on the Real-Time Monitoring tab. Utilize the maximum capabilities to solve business tasks together with Sigur. That's all from me. Until we meet again.